Hi students, today we're going to finish chapter 12, section 1. Gravity. Gravity is an attractive force that pulls objects together. Gravity usually acts towards the center of an object. You even have an attractive force. So gravity, you do have an attractive force, gravity, but you don't notice it because the earth is so massive that everything is attracted towards the earth instead of towards you. So gravity depends on the mass of the objects. Like I said, the Earth is so massive that everything is attracted to the Earth on Earth instead of other objects, and the distance between the objects. So the Earth is much larger than you. Its attractive force is much larger than yours. Falling objects. Gravity causes objects to accelerate downwards. All falling objects accelerate at 9.8 meters per second squared on Earth. You will need to know that number. I will not give that number to you on tests, so make sure you memorize that number. Terminal velocity is the fastest velocity that an object will obtain when falling. As an object falls, at some point during its fall, it will hit its maximum velocity. And at that point, it is no longer speeding up as it falls. So if something falls, every object has its own terminal velocity, and then it won't accelerate anymore, because it usually is because of gravity, but at some point gravity will not make it accelerate anymore. It's when the gravity is equal to the air resistance pushing it up. So those two accelerations cancel each other out, so it does not accelerate. Projectile motion. Projectile motion is motion of a falling object, which is called the projectile, after it is given an initial forward velocity. Gravity and air resistance are the only forces acting on a projectile, and projectiles always follow a curved path. Some examples of a projectile are anything being shot out of a catapult or a bullet being fired. Calculating for falling objects. Distance equals 1/2 acceleration times the time squared. I will give you this equation on the test, and you don't need to know how to rearrange it. So distance is equal to 1/2 times a times t squared. Make sure you realize that the acceleration, the a, is always 9.8 meters per second squared. I won't give you that number. D always has to be in meters, and t always has to be in seconds. Velocity is acceleration times time, and I will give you that equation as well. I will give the v equals at, and make sure you always remember that the acceleration is always 9.8 meters per second squared. V is in meters per second, t is in seconds. So if a ball is dropped off of a bridge, how far has it fallen after 2 seconds? If you're looking for how far, that's looking for the distance equation. So you'll always start with the equation. Then you will fill in what you know. So our distance is equal to 1/2 is the same thing as 0.5. So if you want to write 0.5, you can. Our A is always the 9.8 meters per second squared. And just because the seconds is squared in the unit does not mean that you actually square the 9.8. And then we're going to take 2 seconds and square that. So the first thing you want to do is take your 2 and square that, and so that actually would become 4 seconds squared. So then you'll take your 4 times your 9.8 times your 0.5. When you take 4 times 9.8 times 0.5, you get 19.6. The second squared here cancels out with the second squared there, and so you'd be left with meters. The next question, how fast is it going? That's looking for velocity, so you're going to use your velocity equation. And remember, your A is your 9.8 meters per second squared. You don't have to worry about squaring the 9.8. The square is just part of the unit. And then you multiply it by 3 seconds. When you multiply those together, you get 29.4, and for units here, the seconds here only cancels out with the squared here, so you're left with meters per second. That's it for today's notes.